put the following repeating decimals into fractional form. So this definitely falls under the heading of a series problem. So for instance, if I took 0.123, that's going to be the same as saying 1/10 plus 1/10 squared times 2 plus 3 times 1/10 cubed, and so on and so on. There's always going to be an n, 1/10 to the n in front of each of our numbers as we keep going out. So definitely a series problem. So let's take a look. My first one, I'm going to have 0.123, and then the 123 is going to keep repeating. So let's write that out. So x is equal to 0.123, 123, giving it a name x so that I can do algebra by manipulating x. Okay, if you want to put decimals that repeat into fractional form, you just pay attention to how the cycle works. Here, it's going to cycle every 3. So what I'm going to want to do is, I'm going to want to multiply by 1,000, because what that'll do is it'll push one cycle past the decimal point. And then you notice, if I take a difference, everything on this side of the decimal point disappears, leaving me with terms that are only given in terms of integers. Okay? If I want a fraction, it's always integer over an integer. There are no decimals to be seen. So let's take a look. I'm going to multiply by 1,000. It gets one cycle passed. Take the difference. That gives me the 123. And then on this side, I have 1,000 for the bottom part minus x, top part, which is going to give me 999x. I get x by itself, and then I can reduce that to 41 over 333. Of course, I could check this if I have a calculator. We just pop those numbers in and see what comes out, and that works out to be that on my calculator. Something a little bit more complicated. So say we have our cycle starting late in our decimal. So that means we're going to have some junk loaded up in the front that we've got to deal with. That's okay. All I need to do is start the same way. Call your number x, and then we just want to line things up at the decimal point. I want to line up one cycle right before the decimal point, and then another cycle on the other side of the decimal point. So in a way, we really don't pay attention to this here. We're just going to get one cycle before the point, one after the point. Then when we take the difference, all the cycling stuff's going to disappear. So let's take a look with this example. So 5.23, and then the 1, 2 repeats. So we write that out. So if I want to get one cycle up against the decimal point, I only need to multiply by 100. That's going to get me past the 2 and the 3. So as so. If I want to get one cycle on the other side of the decimal, we'll have to multiply by another 100. Okay, 10 gets me the 1 out, and then another 10 gets the 2 out. So that's going to be multiplying by 10,000. Now, you'll notice when I take the difference, everything here drops out, leaving me with an integer minus another integer. Okay, so that's going to give me 51789. On this side, I'm going to have 10,000 minus 100, which gives me 9,900. And then I just isolate x like before. So I'm left with 51,789 over 9,900. Of course, I'm going to go, if I have a calculator, I just check it. And for this example, it checks out on my calculator.